Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a nice system of equations. We have 2z plus 3iw equals 5 and zw equals I. This problem was suggested by highly educated trucker 4986. I love your problems. Please continue to suggest problems. Alright, so I'll be presenting two methods, and let's start with the first one. So for my first method, I'm going to replace z with a plus bi and w with c plus di. Okay? So if you do that, you're going to get 2 times a plus bi plus 3i c plus di equals 5, and a plus bi times c plus di equals I. So that's the system of equations. Let's go ahead and distribute and simplify. Separate the real and imaginary parts. 2a minus 3d, we get I squared here, which is negative 1. So it's 2a minus 3d plus 2b plus 3c multiplied by I equals 5. And then from the second equation, we get ac minus bd, and then plus adi and bci. Put those together, and now we got another system. Now if two complex numbers are equal, remember their real parts are equal, the imaginary parts are equal. So here this needs to be 5, and this needs to be 0, and this needs to be 0, and this needs to be 1. That gives us 4 equations. Let's go ahead and write them down. 2a minus 3d equals 5, 2b plus 3c equals 0, ac equals bd, and AD plus BC equals 1. Okay, so now notice that from the second equation we can solve for B or C. Let's solve for C. We can write the C as negative 2B over 3, right? And then from the first equation we can solve for D. That's going to be 2a minus 5 over 3. So these will come in handy when we start solving the problem or the equation. Now let's take a look at the third equation. Now we have AC, so let's replace C with this. A times negative 2b over 3 equals BD, right? And D we can replace with this. It's going to be 2a minus 5 over 3. So this is nice because we only have 2 variables, so we're going to be able to solve one of them in terms of the other. This gives us negative 2ab over 3 and 2ab minus 5b over 3. You can cancel out the 3's and put everything on the same side. 4ab minus 5b equals 0. And then you can factor out a b. This gives us 2 solutions, right? Either b is equal to 0 or 4a minus 5 is equal to 0, which means a is equal to 5 over 4. Let's go with the first one first. What happens if b is equal to 0? If b is equal to 0, notice that we have ac equals bd. If b is 0, then c is also 0, because c was written in terms of b, remember? Negative 2b over 3. So if b is 0, then c is also 0. Awesome. But we have ad plus bc equals 1. So if b and c are both 0, then ad is 1. So from here we can write AD as a times d, which was written as 2a minus 5 over 3. Remember, we were able to write d in terms of a. So a times 2a minus 5 over 3 equals 1. Let's go ahead and distribute. 2a squared minus 5a is equal to 3. 2a squared minus 5a minus 3 equals 1. And notice that we can easily factor this equation if you think about it, or you can use the quadratic formula too, but I would just say, hey, this can be factored as 2a plus 1 and a minus 3. Okay, from here we get 2 a values. Let's go ahead and take a look at each one. A is equal to negative 1/2, or a is equal to 3. Now, if a is equal to negative 1/2, remember, ad is equal to 1, so d is the reciprocal of a, right? So if a is equal to negative 1/2, d is going to be negative 2, right? And then if a is equal to 3, then d is going to be 1/3. But remember, we already found B and C, they were 0. So B is 0, C is 0, B is 0, C is 0 in this case. So from here we can write our numbers. Z is A plus BI, which is -1/2 plus 0i, and W is going to be C plus DI, which is -2i. So it's going to be one solution, and the other solution is going to come from the second one, and that's going to be Z equals A plus BI, which is 3 plus 0i, and W is going to be C 0 plus 1/3 of I. Okay, so that's going to be another pair that satisfy our system. One thing we didn't check though, right? We checked all the cases except for this one. So if this is done, we haven't checked this one. So let's go ahead and check that one now. A is equal to 5/4 gives us the following. D becomes 4/5, right? Were A and D reciprocals? Yes. Okay, so A and D are reciprocals. And then from here, what we can do is we can go ahead and plug this into every single equation that we have. D is equal to that. C is equal to -b/3. Let's see what else we have. We have the 2a equals, okay, we have the D in terms of A. Let me see. And then 2b plus 3. AC is equal to BD. Okay, that should help. AC is equal to BD. Now AC is going to be -10b/12, and BD is going to be B times 4/5. Okay, from here we get something for BN. Okay, so here's the problem. From here we get B equals 0, right? If A is equal to 5/4, then B is equal to 0. If B is equal to 0, then I think C should also be 0, right? From this one. AD is equal to 1. Let's see. C is equal to -1/3. Yeah. So what happens is the solution from here is not going to satisfy the original equation. If you go ahead and take a look, of course, C is going to be 0 as well. So A plus BI is just going to be 5/4. Well, that's going to be our Z. And W is going to be C plus DI, which is going to be 4/5i. Let's go ahead and plug it in and see if that works. 2Z is going to be 5/2 plus 3i times 4/5i. This is I squared, which is -1. 5/2 minus 12/5. If you make a common denominator, 1/10. That's not going to give us 5. There's a problem here. And ZW is also not going to satisfy. Actually, that's going to work, but first equation is not going to work. So we had the quadratic, remember? So we were supposed to find two pairs of solutions. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.